This problem, if you see, I'm getting an idea of uh, using geometry here, right? Because I've done similar problems. So where is the pen? Yes, okay. So this is an equation of a circle, and similarly this as well. So let me just complete the squares. So x square minus 2x. So this seems like x minus 1 whole square, which is x square plus 1 minus 2x. Okay, so we already borrowed 1 from here, right? So we are left with 18. Okay, and we have y square plus 6y plus 18. So this becomes y plus what? Y plus 9? No. uh okay, I think we'll be okay. So y plus 3 square if we do, so y square plus 3 square, which is 9 plus 6y. Perfect. So we left with 9. Okay, so the first root becomes something like x minus 1 square plus y plus 3 square and plus 3 square. Okay, now for the second root, similarly I'll do the same thing. So we have x square plus 8x. Okay, so this seems like x plus 4 whole square, right? So x square plus 16 plus 8x. Okay, so we borrow 16 from here, so we are left with 5. Okay, and now we have y square minus 4y. So we can take 4, right? So it becomes y minus 2 whole square. So that's y square plus 4 minus 4y. Perfect. And we'll be left with what? 1? Yes. Okay. So my second root becomes what? It becomes x plus 4 square plus y minus 2 square plus 1. Okay, now let me remove this mess. So we have to find the least possible let n. Okay, whatever. So this actually, if you see it, this thing actually okay, this is telling us that we have to, there's a point xyz, right? In 3D, or you can say we have to find the shortest distance of x comma y, right, from the point -1. Okay, -1, sorry, not -1, 1, -3 and 3 and -4, 2 and 1. Okay, so basically the x comma y is a point in 3D, and we have to find the shortest distance, right, such that we minimize basically x comma y, such that the sum of its distances from both these points is minimum. So that we can do using reflection property, right? So basically if you see my all of this is happening in my z equals to 0 plane, right? Because these points are fixed points, right? Okay, let's just reflect this point in this plane. So we'll get -4, 2, and the reflection of 1 in z equals to 0 is -1, right? So we have to find basically the distance between this and this. Okay, so the distance between this is what? 5. Okay, 5 square plus 5 square plus 4 square. I think I'm wrong, let me just check. This is 16, 56. Okay, I'm correct, 66. Yes, and they asked us to find n square, so n square becomes 66. Okay, so little different because we are used to solving about 2D, but they use 3D here, but it's still doable. So